So let's look at the question. The question says we need to write an efficient algorithm which searches in m into n matrix, and it says that all the rows, the integer in the rows, they are sorted from left to right, and also it says that the first integer of each row is greater than the last integer of previous row. Let's look at the examples. So some examples are given in which we see that all the rows are sorted. So we will look at what is given and what we need to find. So let's first change to Java, and then we'll write what has been given to us and what we need to find out. So as with all the questions, we are given some input and some output is expected, and we need to create a function for this. So the very first thing which is given to us is that we assume that for now the matrix is sorted row wise, and we are overlooking at the detail for column wise. So first we will try to solve it row wise sorted matrix. What we need to find out is that we are given an element and we need to find out if this particular element is existent in the matrix given. Now let's look at the constraints. Okay, so the constraints are pretty generic. There is nothing to worry about. Now let's look at what kind of output is expected. So the output expected is boolean, so we need to write a function which returns a boolean output. So we will start with the simplest solution. The simplest solution as per the details given would be that we go to each row, and because each row is sorted, we can apply binary search for it. So what we will do, we will loop over the whole matrix row wise, and for each row we will do a binary search. So that should work. So let's look at the code which we need to write in order to create this particular solution. Here the arrays.binary search is a Java library function. If the element is not present, then it will return -1, else it will return all the elements which are coming before the insertion point of the element. So this should work, and this worked actually, but this is a pretty simple explanation of what we are trying to achieve here. Great, this was easy, but what we can do more, right? We can do some kind of optimization here. So in order to find out the optimization, you need to watch the whole video, and do not forget to share and subscribe to the channel. But before moving to the optimized solution, we will try to find out what is the time complexity of our current solution. So the time complexity of our current solution can be found out from the loop which are being put in the solution, and we see as the outer loop runs for all the rows which are m, then for each row we go for binary search, and so it would be O of m into O log n. Given m is number of rows and n is number of columns, that is number of elements present in each row. But we can definitely improve upon it, but we need to think about what kind of intuition is coming into our mind, what kind of solution improvement we can do here. One thing which we can definitely do is that as we know that each row is sorted from left to right, we can skip over the rows. We can try to find out that if a particular row is containing our element or not by comparing our element with the starting and the ending element of each row, and then we can skip. So let's look at the improvement. Let's try it. We will put an if block looking for the first element and the last element of the matrix row, and we'll be matching that with our target. So if our target falls into that particular row, we will go for the binary search. Else we can just skip over. So first we are making sure that yes, our target could be present in this particular row, else we will skip over it. Then we are searching for it. So this should give us some improvement in terms of total time taken, but we need to look at the function that if this is improving our time complexity. So that's a tricky one. And once we have found out that if this particular solution which we have just optimized is having the same time complexity which was there earlier, or the time complexity has increased or not, then we will move to the intentionally overlooked detail, and we will see how with the help of that we can improve our solution in terms of time complexity also. So as you are seeing that in terms of time complexity, our solution is still the same. It's still O m into O log n. So as the outer loop is not reducing in terms of total number of loops, total number of iterations, the time complexity remains same. But yes, with the help of overlook detail, by including that into our function, we can definitely make some improvement, and after making that improvement, we will see how our function time complexity improves. So the detail which we overlooked was that the first integer of each row is greater than the last integer of previous row. What it says in the simplified terms is that not only the matrix is sorted row wise, but it's also sorted column wise. So we can definitely make the assumption that each time we are moving to a different column within the same row or different column from the last column, we will be having higher values. So instead of looping over all the rows, what we will do, we can first choose which row we want to go in using binary search, as we now know that the columns are also sorted. What we will do, we will start from the very first row, which is the 0th row, and we will go till the last row. Then instead of writing arrays.binary search, as we need to do the binary search in its raw form, we will write the whole while loop for binary search. How I am performing it here is that I am going to the mid index, and then in the mid index, that is the row index, I am trying to find out if that is our required row. If it's not, we will move either to the upper section or the lower section, hence reducing the search space. So either our target will be present in the upper section or in the lower section. We will move to the either one, so reducing the search space. Eventually, min and max will be pointing to the same index, same raw index, and then we would search into that raw for our element. So what we are doing in this case is that we are separating the logic of finding the row and then searching in the row, hence reducing the total time complexity. But what we need to find out is that if this particular while loop is performing what we are expecting out of it, let's try this solution. Hey, it didn't work, but why did the time limit exceeded? Let's try to find out where we are doing wrong. Definitely, our while loop is not performing as per our expectation. Let's think over it. You also try to find out where the code is not doing the right. So if you look at this while loop, what is happening here is that although we are saying that we are trying to reduce our search space, we are not doing that quite right. Plus, there is a mistake at line number 16 in which the max of raw would be matrix.length minus 1. If you haven't not been able to figure out where we are doing wrong, just wait for a couple of seconds and you will see what is the thing which we need to include in such kind of solution when you are trying to do a binary search. So what we are doing here is that we are not reducing the search space in the right way. What we need to do, we need to look for a specific element or an index or a part of our matrix. Then if that element or part is not ours, then we need to leave that particular part and go in either upper section or in the lower section. So what we are doing now is that for the target, we will look if the mid index row is having our target. If it is, then it's our row. If it is not, then we will do either mid minus 1 or mid plus 1 and we will search into that search space. So as you see, from line number 20 to line number 24, what we are doing, we are searching for our target in a particular row. If that is there, then we will do max is equal to mid and mean is equal to mid, saying that this is our row. But hey, there is one more thing which we need to do, and after that our solution should work pretty fine. What if the element is not present in our matrix? In that case, the max would come minus 1 because there is no such element. Such kind of edge cases are needed to be covered while we are performing our function, else within an actual interview some points would be deducted out of it. Great, after performing these changes, after making these changes, now our function is working pretty fine and the overall time complexity has now come down to O log of m plus O log of n. As both finding out the row and looking into the row are two separate parts within the same function. Hence, we are having O log of m plus O log of n